Hey guys, Mr. Burns here with your video for lesson 14T, using probability to predict. So far in lesson 12 we talked about fractions, decimals, and percents, and how to change one to the other. On number 13 we got introduced to probability and how you can use probability and what probability is and the different types of probability. Remember that one type of probability is theoretical probability and the other type of probability was experimental probability. In this lesson we're going to be focusing on experimental probability. Okay, and experimental probability is used to make predictions, okay, in a real world setting. Okay, so here we are on number 1. Number 1 says you plant 10 tulip bulbs and 8 of them bloom. Part A says find the experimental probability that a tulip blooms. So in this case you're actually performing an experiment. And what did you do in this experiment? Well, you planted 10 bulbs. And out of those 10 total bulbs, 8 of them bloomed. And just like in anything else in the previous blocks, we're going to go ahead and reduce our ratio here. So the greatest common factor between 8 and 10 is 2. 8 divided by 2 is 4. And 10 divided by 2 is 5. So there's a 4 out of 5 chance that your tulips will bloom. So let's check out part B. On part B it says if you plant 5 more tulips, predict how many of those would bloom. Let X equal the number of tulips that bloom. So here we go. So your proportion is X. What does your proportion start off with? Well, our proportion started off with what our experimental probability was, which was 4 out of 5. So 4/5. Now you plant 5 more. That's where that 5 came from. And they want to know how many of those are going to bloom. So what's the expectation? So here we go. We're going to solve for X. So just like before, we're going to cross multiply and then divide. So here we go. So I'm going to go 4/5 is equal to X over 5. So we're going to cross multiply. So 5 times X is 5X. And then 5 times 4 is 20. Divide both sides by 5, and X equals 4. So the answer is about 4 more tulips will bloom. Now, some of you guys might notice, hey, Mr. Burns, why did you have to go through all that when the denominator didn't change? It stayed 5. Well, that's a great question. This here proves, in fact, does prove the fact that X equals 4. So it's just a part of showing your work in math. All right? We're worried about precision in math. Let's take a look at number 2. On number 2 it says Mo had 2 goals in one game out of 6 shots attempted. A says find the experimental probability Mo will shoot a goal when attempted. Well, how many shots did he attempt? He attempted 6 total shots. Out of those 6, how many did he make? He made 2. So what's the experimental probability? Well, we have to reduce our ratio first. So what's the greatest common factor of 2 and 6? The greatest common factor of 2 and 6 is 2. So I'm going to divide both the numerator and the denominator by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So there's a 1 in 3 chance that Mo will shoot a goal when attempted. All right, part B says Mo has 9 attempts in a game. Predict how many goals he scores. So part A says let X equal the number of what? Well, that's the number of goals he scores. Oops, not moving around. That's the number of goals he scores. So let's go ahead and set up our proportion. In our proportion, the experimental probability is 1 in 3, and then this part of the proportion represents the game. So for part X, let's go ahead and solve for X. So we've got 1 out of 3 equals X over 9. Cross multiply, so 3 times X is 3X, and then 9 times 1 is 9. Go ahead and divide both sides by 3. So multiplying by 3 and divided by 3 cancels out, and that leaves me with X equals 9 divided by 3, which is 3. So about 3 more goals. All right, let's go ahead and jump to the backside. Okay, here we are number 5. Number 3. Number 3 says, rangers in Central Oregon wanted to estimate the number of elk in a certain area. They tagged 10 elk one Saturday and sent them back to mix with the other elk in the area. The rangers went back once a month for the next 3 months and recording the following data. Okay, so let's go ahead and underline some important information. Initially, what did they tag? Initially, they tagged 10 elk, on one Saturday. And the chart here, shows what they tagged these next 3 months. Okay, in month number 1, they had 8 elk in the sample, 5 of which were tagged. Month number 2, there were 10 elk in the sample, 5 of which were tagged. And then month number 3, they saw 12 total elk in the sample, and 8 of those were tagged. Part A says, estimate the size of the population using data for month number 1. So the number of tagged elk in the sample. So how many elk were tagged in the first month? 5. Out of how many? 8. All right, and then the number of tagged elk. So what did they tag initially? They tagged 10. And that's it. Next thing you have to do for part A is go ahead and solve the proportion. So we're going to go 5 out of 8 is equal to 10 out of x. Go ahead and cross multiply. So 8 times 10 is 80. And then x times 5 is 5x. Divide both sides by 5. And you get x equals 16 elk. So that's what we're going to predict is in the population. Let's check it out. Part B. It says estimate the size of the elk population using the data for month 2. So in month number 2, what were the number of tagged elk in the sample? There were 15 tagged elk in that sample. 5. Out of how many? 10. Okay, and then let's see. If we're going to calculate the population, the total population that's going to go on the bottom, and how many initially were tagged? 10. So let's go ahead and solve for this one. So we've got 10 times 10, that's 100. And then 5 times x, which is 5x. And we're going to divide both sides by 5. And this is going to give me the estimated population for this elk herd, okay, using the data for month number 2. So x equals 20 elk. So using the data from month number 2, that is the estimated population, okay, for the elk in this herd. Let's check out part C and D. Okay, for part C, it says estimate the elk population, okay, using the data from month number 3. So let's go ahead and set this up. So for month number 3, 8 were tagged out of the 12, okay, elk that we're seeing. And that equals, okay, the total amount of elk, which is x, because that's what we don't know, okay, out of the 10 that were initially tagged. So let's go ahead and solve for x. So we got 12 times 10, that's 120, equals 8 times x, which is 8x. And then we're going to divide both sides by 8. And then we get x equals 120 divided by 8, which is 15 elk. So using the data from month number 3, we can estimate that there's going to be 15 elk in the population. Alrighty tidy. Let's check out part D. Okay, finally on part D. It says find the average of the 3 estimates for month number 1, 2, and 3. So the estimated elk population for month number 1 was, it's 16. Plus the population from part B, that was 20. Plus the population from part C, that was 15. And so we've got 16 plus 20 plus 15, that's 51. And to find the average, I'm going to divide that by the 3 months, and then 51 divided by 3 is 17. So we can estimate that the population for this elk herd is going to be 17 elk. All right, that's it. Paper, pencil, calculator. Let's get ready to crack-a-lack it.